All right, everyone, we're going to take a look at activity 1.1.2, simple machine practice problems, and in this one we're going to be looking at 4, 5, and 6. So this is kind of the grouping of questions that we're going to work from. So in number 4, here's kind of our scenario. A wheelbarrow is used to lift a 200-pound load. The length from the wheel axle to the center of the load is 2 feet. The length of the wheel and axle to the effort is 5 feet. So here's kind of our sketch here. Imagine we have a fulcrum right here at the ground. So a wheelbarrow is going to have a wheel that goes through and has a little bit of a pivot point. Here for a second class lever, let's say this is kind of imagining here's our wheelbarrow. If you wish to go through and kind of get an idea, you could kind of go through and look at putting in like a little kind of bucket or something like that there to kind of go through and help you visualize. However, here's what we have going on. 200 pounds is going to occur right here in the middle. We know that we've got an effort force that is going to be put right here. So they say that the length from the wheel axle to the center of the load is 2 feet. So from here to here, 2 feet. Put my arrows on the outside there. And then the length to the effort is 5 feet. So I'm going to just extend this out, put 5 feet in there, and go from here to here. So that completes our sketch. You know, we went through, and what we don't know is what is our effort force. So the first thing in number 5, they're going to ask you for what is the ideal mechanical advantage of the system. So when I look at my formula sheet, my IMA is dE over dR. So D standing for the distance to the effort. The bottom one's going to be distance to where the resistance is located. So here's what I go through and I take a look at. Substitute and solve. Here I have the effort is 5 feet. And here, note the significant figures. I kind of left those off in the image just to kind of fit it all in. But here I've got 5 feet, and on the bottom I have 2 feet going on. So what's going to happen here, again, as we kind of talk a little bit about significant figures and things of that nature, when we get an answer here, we're going to make sure that our answer is going to go through and fit to match the level precision. So they specifically have put in that we have 3 significant figures. So as I go forward, I can go through and I'm just going to divide these out in this scenario. So if I go through and take 5 divided by 2, that's going to go through and give me 2.5. So if I go through and look at this, 2.5 over 1, that means my IMA is going to be 2.5. Now since I got 3 significant figures, I want this to match as well. So 2.50 to 1 for my ratio. So that's going to complete number 5. As I take a look at number 6, now they want us to look at the static equilibrium equations. So as I kind of scroll up here just a little bit, so using static equilibrium equations, calculate the effort force needed to overcome the resistance force. So as I go along, static equilibrium, same formula as what we saw in the previous kind of scenario with numbers 1, 2, and 3. Fe times dE equals Fr times dr, and I'm going to plug in what I need. So Fe is our unknown. I'm going to multiply that by where the effort is, so this is going to be times 5 feet, is equal to, so here we have 200 pounds, and we have 2 feet. I'm going to run out of a little bit of room there, but we can go through and we can kind of see that. So then, as I go through and I solve for this, Fe is going to go through and come out to be, as I work through some of the simplified versions. I'm going to go ahead and make sure to use this in my calculator. So 200 times 2, so that'll be my right side of the equation. That gives me 400, just to kind of show you the process here. Fe times 5, And I'm going to do just a little bit of simpler terms here. It's equal to 400, and I got to divide by 5 on each side. So once I do that, I'm going to be able to get the amount. So in this case, my FE is going to be 80. Now when I go through and I look at the level of precision, that 200 pounds only goes to 1 decimal place. So I'm going to go ahead and I'm going to record it to the same. 80 pounds of effort that I need to be able to lift the wheelbarrow. That's how strong I have to be to go through and do that. So this finishes up numbers 4, 5, and 6. So again, check your work, see if you got the right answer. If not, come ask me questions, and that way we can get you taken care of.